which you have been registered. I think all those who have registered the same mail IDs, I have sent the link of in Google Calendar. You can just check out in the meetings so that you will not face a problem of getting admitted in every session. Please join into the same mail ID which you have received the invitation for the meet. Start the session as soon as sir joins. Good afternoon, sir. Yes, good afternoon. Friends, hope you had lunch. We are just waiting for some resource person to join. So in the first session, we had a wonderful session where introduction to MATLAB programming was done. So I hope all participants have been hands-on on how to log in through MATLAB, what is the user interface, and all the basics of MATLAB. Sir has very well explained about it. And now in the next sessions, I will be speaking about the certification courses, how you can do the courses, and DSPs. So we'll be studying basics, because these are the basics things which you require for studying deep learning ML using MATLAB. As you can see on the screen, the schedule, we'll be covering in this session signal processing and DSP systems. Tomorrow we'll be having how machine learning and deep learning can be used and to solve many applications using MATLAB software. So what is the aim of this PDP is, since we have all Atharva students and faculties in the PDP, our college has the MATLAB license version, unlimited version, we have subscribed. So we want all the students and the faculties to take advantage of this, learn this software, and add on to your resume one more skill. It's a professional skill where MATLAB is used in many industries. So you can use it in remote places if using your Atharva IDs. So please utilize this since you are having this license and you can do many projects. Sir will be putting insights on different kinds of projects, different competitions also, and how MATLAB can be utilized for covering up many latest applications. So tomorrow we'll be having insights on machine learning and deep learning. And on the third day, we'll be having insights on building AI applications for signal processing, like using different applications like wavelet scattering, spectrogram, ECG. And will be a request to all the participants, the certificate courses have been listed out. You have to kindly do it, get your certificate, and by the end of the third day, we'll be sharing one final feedback form for certification, where all the certificates have to be attached, because these certificates have been will be verified with the company, and then at the end, the certification of the completion of the course will be given to the participants who complete all these courses. So these course certificates, you need to submit it in the Google form, which will be shared on the third day. And since on the request of many participants, I will be sharing this recordings. I'll be creating a Google Classroom and I'll be sharing in the WhatsApp group. So please join the Google Classroom, and all the materials sent by sir, video or a document, and the recordings of each session, I'll share it in the Google Classroom for your further reference. Any doubts, students? Or any other faculties? Any doubt? Please let us know when we can start. And post this session, each day you will be getting a feedback link for every sessions. Kindly please fill the feedback forms. One form will have feedback for both the sessions. So total 3 feedback forms. And the last feedback with the uploading of certificates will be the 4th feedback form.
Yeah, thank you, ma'am, for briefing all of us.
Thank you, sir.
I think we can wait for one more minute since
Yeah, sure.
I had continued for 10-15 minutes in the first session. And,
No issues. Yeah.
and as you have said, I will be driving them through how to access the on-ramp certifications. At the end of the session, I would also be telling them about Simulink drone competition. And let's see if few of them show interest, then we can plan another activity for them. Okay.
Sure, sir. We'll be eagerly waiting for organizing such competition also.
Yes, ma'am. Yeah. Okay, dear participants, I think now it's time when we can move ahead and we can start with the second session, that is with signal processing.
Yes, sir.
And other stuff. Okay, let me share my screen. So, as briefed by ma'am, we will be first discussing about, I hope my screen is visible, right?
Yes, sir.
Yeah. So first what we'll do is we will go to a browser and we will type MATLAB Academy. Now, if you type MATLAB Academy, this MATLAB Academy is the best place for the new MATLAB user to start with. As you can see over here, there are code examples, documentations, and videos, okay, on the product capabilities. And here you may see we have this MATLAB on RAM, signal processing on RAM, machine learning on RAM. So today, when you have time after the session, you need to complete this certification course, which is MATLAB on RAM, as a part of the first session. In the second session, we are going to focus on signal processing on RAM. Okay, so you should complete this particular, what you can say, this course. I'll let you know that how to do this course, okay, before we start with signal processing. If you feel like you are looking for some other examples or video, you can go ahead, okay? And what I want to do is I want to take you to the learning path. Now, most of you might be thinking like you belong to different domains, so you might have thought of a different learning path over here. If I click on explore all the learning path, I'm sharing the screen, I'm sharing this link with you in the chat window. So what we are supposed to do is we are supposed to go to the learning path. And you can see that there are 14 learning paths. This learning path are core MATLAB skill, build MATLAB proficiency, visualization in MATLAB, programming in MATLAB, data analysis, and then you have a certification course over here, which is MATLAB for MathWorks Certified MATLAB Associate. Thinking that you need to, work with signal, you'll go with core signal processing techniques in MATLAB. I have highlighted this in the agenda as well. Okay. Later on, you can complete this task like we are going to complete this, some fundamentals, and you will complete this deep learning with MATLAB for image applications and machine learning techniques in MATLAB. Okay, let me go back to the course that I was talking about. So since you all have a campus-wide license with you, you can go to this course, MATLAB for MathWorks Certified Associate Exam. As you can see, there are many courses in this particular certification. I think there are more than 14 courses over here. And this 14 courses talks about few of the things that I have tried to cover in my session. So I've covered some part of this, explore data, something sort of this. Okay, and you can see everywhere you'll find out completed. But you won't see, any certification over here because I have not completed this particular course. However, I have completed the individual courses in this particular certificate, right? Certificate course. So let us suppose I click on, okay, I hope you're able to access this, right? Let me click on explore data with MATLABplots. If I click on this, you might be able to see, I have got over here, share course, certificate and progress report. I can click on certificate and progress report. I can view the certificate. So see, this is a certificate. Right now it's showing 0%, it's fine. I can start again and it will show me 100%. Okay, fine. If you want, you can share this in your LinkedIn as well. Okay. If you're looking for progress report, and if you're looking for progress report, you can click on view PDF and you would be able to see that different modules are there. Okay. Now, see what are the advantages of this, I'll tell you. So if I go back to, get your digital credential, if you can see over here, get your digital credential. I have already completed few of the courses. If you go to completed, you might be able to see. I have completed so many courses over here, right? So let me go to home and let me go to learning path and let me click on build MATLAB proficiency. So this is a particular learning path that I've completed. And you can see over here that learn more about digital credentials. So if I click on this digital credentialing certificate and click out digital credentialing, okay, get your digital credential. Let me click on send request. Okay. And then you can see it tells me that your email notification, you might receive an email notification from credly.com. Okay. So click OK, go to your inbox. In my inbox, see, it shows me congratulations on earning your digital credential from MathWorks. Let's click on view details. And I have a link over here where I can manage my profile. Okay, fine. So accept all. Let me sign in. And if I sign in, you should be able to see that I have got this badge. And this badge is issued by MathWorks. Now see, since you all are under campus-wide license, your instituted purchase license, you are freely available to complete this course and share your badges with us. We'll be also happy to tell our other customers that participants at this institute have completed this kind of courses, right? So you can see there are many courses over here, related courses. If you think like you need to share this, click on share, okay? And you have an option over here, LinkedIn, Facebook, Twitter. You want to email, you can send this as a batch, public link. I will click on download a batch. So it has some version. I'll choose the latest version. Click on download image. So the image is getting downloaded over here. And then I would be happy to answer this. And now let's click on view dashboard. So if I click on view dashboard, you might be able to see, dollars is 0 for me. Why? Because I have access to all this particular courses. Go to downloads, click on this image. So this is MATLAB proficiency.png. Click over here. Now this is the batch that I was talking about. Right? I hope that you would be completing this particular courses. Okay, at least core signal processing techniques will be very useful for students from electrical background, EC background, mechanical background, also machine learning and deep learning. I hope this is clear. If you have any doubt regarding this, please let me know. I'll be happy to guide you through this. Fine? Okay. I'll just close this. Okay. So any doubts, anything you want to ask? Fine. Let me quickly show you. You go to home, click on the first course, that is MATLAB on ramp. I am sharing this link with you. You need to complete this certification course and share it in your Google Classroom as briefed by ma'am. Okay. How to launch this course? So, you might be able to see over here, I'm getting resume course. So I can click on course overview, and let's say I can click on start module. So you can go to any module and you can start completing the course. If you see, this course MATLAB on ramp is a module of other courses: core MATLAB skill, explore data with MATLAB plots, MATLAB desktop tools, and troubleshooting scripts. Right? Okay. Let me click on course module and start the module. Done? Okay. I'll show you that how you could, utilize this opportunity to complete the course. So if you click on this video, okay. So you would see that oftenly such videos would be there. There is a video and a transcript for this particular video. You can click on next. I'll show you a few of the modules. So you can see now on the left hand side, I've been given a task. Now what are the tasks? The task is to multiply the number 3 and 5. You can press enter. If everything is correct, you should get a green color tick mark. You click on continue, space bar, and you'll move to this module. Now someone can say, okay, I want to go with the module name plots. It's fine. Or data import. Click on plots, plot vectors. You may also notice that on this taskbar, you could see 3% of the course completed, right? Okay. Now you might see that, I have this create a plot with sample on the x-axis and mass on the y-axis, right? I want to create this. And the function that I want to use is plot x comma y. So I can do this. I can take plot. And here I am supposed to write mass 1, comma sample. And here I need to click on submit. So first you can execute the script, view the result, right? And you can click on submit. Let's see if we have got this correct. If you have not got this correct, then, see, we will get this. Did you plot sample on x-axis? Did you plot mass on y-axis? No, I made a mistake. I have plotted mass on x-axis and sample on y-axis. So let's try to rectify our mistake. Now let's try and execute the script first. Okay. And then click on submit. And you can see I've got this correct. If you feel like you are stuck up at certain step, you have an option for hint. And if you are unable to resolve it, you can click on see solution. So see solution, you can see like we have done the same thing, plot sample, comma mass, plot sample, comma mass. Okay, fine. And if you feel like you want to reset this, you can click on reset. It's fine. You may also notice over here that next to my credentials, Kunal Khandelwal, there is an help button. There's a help menu, question mark. So for few courses, whatever data set or the course that are available with this course could be downloaded as a download course file. You can click on this and you should be able to see getting started underscore course file. And you can download this and you can use this later on, right? If you want to exit the course anytime, you can exit the course. And if you want to come back again after some time and complete the course, you can come again. Okay, your session is reserved. Your session is reserved. I hope this is somewhat helpful to you. Right? Okay. Shall we move ahead then with the next topic?
Yes, sir. Thank you so much, sir.
Yeah, thank you. Okay. I have my MATLAB drive over here, as you can see. And what I want to do is I want to drive you through signal processing and DSP. As I've mentioned, there is already a signal processing on-ramp. So for the first 45 minutes, I would be taking the sample file, sample course, which I've shared with you. And what we'll try to do is in the remaining part, we will try to complete signal processing on-ramp fundamentals in this session itself. Okay, so that you also get an understanding that how this on-ramp courses will help you building the foundation. Okay, fine. Fine. We have over here DSP lab. If you see, if you scroll down, we have DSP lab over here, right? So select the folder DSP. If you do not have this link, I am sharing this link again in the chat window. Will be very much useful for you when you move ahead. Right? You have DSP lab. Click on open in MATLAB Online. Let us close the previous files. Let us type clear in CLC so that I make the environment clear. Done. And now we can do one thing, like if I go to layout and I take 3 columns, you may find out over here that we have different modules over here, module 1 to module 10. And then we have a file over here, which is start_dsplab.mlx. So this particular course contains the fundamental of signal processing and DSP. Let's click on start_dsplab.mlx file. Maximize the window. And as you can see over here, you have table of contents. Right? You have all the contents. You have all the contents, section 1, section 2, 3, 4, 5, 6, 7, 8, 9, 10. And see, they are telling you that before you take this course, you should have at least completed MATLAB on RAM certificate. Now, since we have covered the fundamentals of MATLAB, I am assuming that you have completed this part. Okay, MATLAB on RAM. You need to go to these links
complete the course and submit it later on, right? Okay. Later on, as I've told you, we'll be completing some modules from signal processing on-ramp certificate course. And then since we are going to build up AI model on audio data set, or you can say signal, audio basically I'm saying is a type of signal, okay? Audio signals, images. This particular courses will also be helpful to us. Now, please a quick yes or no will help me in understanding if you are able to access this file. Let's take a minute. You can use yes or no in the chat box and you can explain me, okay, if you are able to access it. Yes.
Thanks, Chintan. Thanks, Sumit. Yeah. Priyanka. Rahul. Okay, I hope most of you are able to access this. Fine. Let's begin with the session. Okay, if you go to the table of contents, you can click on this prerequisite. As I told you, I have already taught you how to create this table of content from the MLX file. Now, this MLX file has been created for us so that we can use this coursework. If you click on this, it is recommended to complete MATLAB on ramp and Simulink on ramp, self-paced course before taking up this course. Not an issue. If you click on MATLAB on ramp, it will take you to another browser and will take you to the same link where the one which I've already shared with you, where you can go and you can complete this course. Next. Just a second. Just a second, guys. Okay, let me share the screen. Yeah. Okay. It will take you to the on-ramp, MATLAB on-ramp. Fine. We are interested in moving ahead with our DSP part. Now see, since we have all the folders over here, folder number 1 to 10, and these folders may have some files which are dependent to each other. Therefore, what we can do is, you can go to line number 1. Now remember that this is a section, line number 1, and click on add to path, add path, generate path, current directory. What this instruction will do, it will add all the contents over here to the MATLAB path. If you do not do this, the modular script is not going to work. Am I clear? You need to go to line number 1 and you need to click on this blue color strip. If you do not do this, it will give you an error. Okay, fine. Let's move ahead. Now, if you go to apps tab, you're into live editor tab right now. Adjacent to this tab is apps tab. Under apps tab, if you type signal, can you observe? We have got so many apps with respect to signal and DSP application. Few which we want to use today are signal labeler. So signal labeler may not be the part of this course, but I will like to take this, right? Then we have signal analyzer. I have wavelet time frequency analyzer. Okay, filter designer. So at least these apps I will try to cover, okay, under apps. Further, if you go to live editor and you go to task and you type signal, so you get over here this, okay, a task where you can actually create a signal. In addition to this, can you observe design, filter and extract audio features? So extract audio feature is also something that I will demonstrate today. It's not a part of this modular course which you are looking right now, okay? The modular content which you are looking right now. But yes, as we want to build up ML and AI models, I would be taking this extract audio signal. It will be quite a fun to work with extract audio feature app. Let's go to our script. Let me explain you what we are doing in different sections. We are generating some common signals, common waveforms. Okay, we will be working with sampling and Nyquist criteria. Then we'll talk about Fourier transform, filtering, convolution, correlation, data pre-processing. So see, we are interested in this part more compared to convolution and correlation or Fourier transform and filtering. Anyways, like whenever we feel something is not that much important for this particular workshop, we'll try to skip that part. You can complete this at your own end, at your own pace. Fine. Spectrograms, yes. IR filters design, FIR filter design, yes. They are important for us. Not from this workshop point of view, but yes, they are important. Let's go ahead. And let's click on generate signals and common waveforms. Now see how this is arranged. So actually this part is hyperlinked. So when you click on generate signals and common waveforms, this will automatically navigate to folder 1 and will click on signal generation. Fine. And it will get open. Let me show you this. If you get an error and the connectivity is broken, in that case, we need to go to the folder and manually launch this particular file. Okay, I think it's not launching, right? Anyways, so if this is the case, you can go to the files, double click on this signal generation.mlx. And let me change my layout. So go to home, layout, 2 column, maximize, right click, will clear all output. Please, dear participants, let me know if you all are able to access this file. Yeah, thank you. Thanks, Chintan, Rahul, Aditya, Priyanka. Anyone else who is facing any problem? Okay, fine. No issues. Let's go to your MATLAB. So in this particular task, we are going to generate periodic and aperiodic waveform. So you might have generated sine, cosine, step, ramp, impulse, triangular, square wave, so many kind of functions. Okay. Now these are the kind of sequences, okay, which actually help us in understanding the behavior of the signal, okay, and its visualization. So the first thing is go to the section line 1 and 2, click on this script. So what is close all? So if any figure is open, it will close that figure. CL is for clear command window. And then we have clear all, it's for the variables. Okay, is it necessary to write this? No need, like you can simply write clear. Even that is fine. What is next? Periodic waveforms. We have already plotted this if you remember. Let's create a vector. Let's create a vector T. Right? Let's create a vector T. Then I want to plot a sine wave. So we are going to have sine wave is equal to sine of T. Use the plot command to plot sine wave with respect to time T or the vector that we have created. Right? What is next? X label, X label, Y label, right? Can you see over here? Hold on. And another function. Cos of T, and then a legend. Now, if you'll see, let me click on section break over here. The reason is we have all the waveforms. So let me click on this periodic waveform. And under periodic waveform, you have sawtooth function, sine, cosine, square, and all that. So if you see, okay, let me complete the first part. Let's have a section break. We'll go step by step. You can see now we have been able to plot the sine wave and the cosine wave. If you want to rearrange the window, you can rearrange the window. I think this is fine. What is next? Now see, sine and cosine are the primary function. But when we talk about, like we are building up a control system and we are going for some standard test signals. In that case, we may require a RAM signal, a sawtooth signal, a square signal, and so on. But as we are talking about periodic signal or periodic waveform, the MATLAB toolbox offers us a ready-to-use sawtooth function. So this function will create a peak of plus and minus 1 and a period is 2 pi. Right? Okay. We also have over here function, which is a square function. It has a period of 2 pi. And when we talk about square function, okay, we'll try to visualize it, how it's moving ahead. Now, remember this, that when we talk about audio signals or basically signals, we are interested in the sampling frequency. So Fs is the sampling frequency. Now with the sampling frequency, we are trying to get the time vector t. From this time vector, we have this 2 pi 50 t. So t now is a function of this sampling frequency. So we have x1 sawtooth. So if you want, we can write and comment over here. Create sawtooth signal. Next, what do we have here? Create square signal. Okay. Now you see something which is new over here. What is this subplot? I'll explain you what this subplot is. Okay. After subplot, we have option plot. And then if you remember, I have already talked about, using the axis limit to properly view the signal. We have over here X label. We have over here Y label. And the title is sawtooth periodic waveform. We have one more thing over here. What is this? A subplot function. And the next is with respect to the square wave function. So when you use this subplot, what we say? We say that reserve a container or a space for plot. Same thing we are saying over here, reserve a container or a space for a plot. So let me first show you how we are getting the plots, and then I will explain you the command subplot. If you can observe now, the sawtooth waveform and the square wave waveform are in a single figure. So what can I do now? What do I understand by that? I'll tell you. So if you look at line number 18, which is 2, 1, 1, and line number 24, 2, 1, 2. So basically what we're saying, you plot the signal t, x1. Where you need to plot it? So this is 2, that is dividing the entire space into 2 parts. So 1, 1 will be used for sawtooth period, and the remaining one will be used for square periodic waveform. Let me take paint and let me explain you what we are talking about over here. Okay, so we are saying that, okay, let's take a box, let's take a container, you take a line over here. I've got 2 parts now. So when I say 2, 1, 1, I am reserving this space. And when I say 2, 1, 2, I am reserving this space. So here what we are trying to plot? Here we are trying to plot a triangular waveform or a sawtooth waveform, whatever it may be, right? And in this particular plot, 2, 1, 2, we are plotting a square waveform. I hope this is clear. This would be very much helpful to us when I will show you the audio task, feature extraction for audio under the audio task, where you will find out all the figures are arranged like this. Now someone may say that what is the use of this subplot function? Now see, subplot function may be useful for us when we want to accumulate a single category of, what you can say, or the single category of data, or when I want to do some comparison. So I can have over here like figure A, B, C, D in the same figure itself. Okay, let's move ahead. Let me clear all output. Let's move to the another part, which is aperiodic waveform. Now, what do you mean by aperiodic waveform and a periodic waveform? Any idea? Anyone wants to answer this question? I think this is very easy. What do you mean by periodic and aperiodic waveform? So when we talk about sine wave, cosine wave, square wave, we have put them under periodic waveform, right? Okay. Now, okay, let's complete this. By the time I hope you will have an answer with you. Now, if I want to generate triangular waveform, rectangular waveform, or Gaussian pulses, the function that we can use over here are tri plus for triangular, rect plus for rectangular, and Gauss plus for Gaussian. And it's mentioned over here that, okay, when you talk about tri plus function, it generates a sample aperiodic unity height triangular pulse, which is centered about t equal to 0 with a default width of 1. Okay, let's try and do this. Now see, we are plotting over here tri plus and rectangular pulse. So we have sampling frequency fs. You can mention over here, this is sampling frequency. Oh, my bad. Sampling frequency. You have over here time vector. Then what we do, we create triangular function or triangular signal. Next, we create rectangular signal. I've already mentioned you, right? What this indicates, reservoir space or a container, right? This is for X limit, X label, Y label, and so on. Let's try to plot this. So you can say this is a triangular periodic pulse. It is centered around T. Okay, fine. Let me open this in a figure window. Let's try to understand this figure. So if I look at a triangular periodic pulse, and I take an arrow, you can see that this is centered around 0. Same is the case with rectangular pulse also, that it is centered around 0. Now the maximum height here that we are talking for a triangular pulse is how much? It's 1. Similarly, the height or the amplitude for a rectangular pulse is 1. Okay, let's close this. Let's move to another section where we are interested in generating these smooth pulses. So okay, so like you have this Gauss plus function, right, which is Gaussian modulated sinusoidal pulse with a specified time, right, center frequency and a fractional bandwidth. Now when you want to generate a Gaussian function, you use this Gauss plus, okay, and this Gauss plus accepts certain inputs. So a user decides that I want to generate a 50 kilohertz Gaussian RF pulse with 60% bandwidth, right? And which should be sampled at a rate of 1 megahertz. And then we need to define or truncate the pulse with an envelope that falls 40 dB below the peak. And now I want to do this. So how am I supposed to do this? So the first thing is use the Gauss plus function. Okay. The first thing is cutoff. Next, you provide the frequency, bandwidth, and here you provide the gain. So 40 dB is nothing but the gain, right? False is minus, right? Then we create a vector T1, which is from minus TC colon 1. If you can see over here, that is 1 mega, right? To TC. And then what we do, we generate the function. So we have got over here two functions. One is a Gaussian function and one is a sinc function, as you can see over here. you may find out that if you look at the center part, they are almost somewhat similar. But if you look at the peaks, so if I go to insert and if I take an arrow, and if you try to look at this peak and you check the value, you'll find out that there is a difference of values, okay, around minus 0.02 for sinc function and for the Gaussian function. Same is the case at 0.02. I think this is quite clear, right? Okay. Next. Let's clear all output to make things visualize in a better way. So you have over here shift frequency waveforms, right? Okay. Now, here you are using two functions. You can see chirp function. So you can create chirp functions over here. Okay. One will be a linear chirp functions and another will be a quadratic chirp function. Now, when you plot this particular waveforms, that signal, can you notice that it will be difficult for us actually to observe this kind of signal into time and amplitude domain or time frequency domain? Okay, fine. So usually you will find out that such signals are basically plotted in frequency domain, and there could be plotted as spectrograms. So the foundation that we are building for us when we are going towards, applying AI to audio signals or signals is basically feature extraction. And one way to extract the feature is to get a spectrogram. Let's click on this. And you can observe the spectrogram of both the signals. Now see, both are, okay, let me launch this signal also side by side. Okay, I have to generate this signal again since I've cleared the output. Okay. See, you have both the signals side by side. So doesn't matter you're a mechanical engineer, civil, ENTC or you come from any other branch, when you get your data set in the form of signals, visualizing the raw signal with respect to amplitude and time will be quite a difficult or challenging task to you. But if you take a scaleogram of it or a spectrogram of it and visualize this signal, you might be able to observe a distinct feature. So let me explain you what is this figure 2. Okay, you can observe that in figure 2, let me close this. In figure 2, this is frequency with respect to time, first thing that we observe. Next, we look at a pattern of different colors over here. And there is a color bar which has been associated over here. So if I want to differentiate linear chip signal with a quadratic chip signal, how I'm going to differentiate? We look at this yellow color linear variation in the first signal. And then at the center, if I take the things over here, what I can observe? I can observe that the quadratic signal observes a distinct hyperbolic pattern. Okay, what this color bar indicate? So color bar is starting, so if I talk about the first figure for linear chip, it starts from minus 140 to minus 20 or 40 to 1, whatever it's like for you. Just to tell you that the brighter color over here, it's representing higher values, higher frequency values. I think this is sufficient enough for me to make you understand like how things would become pretty easy, okay, when we try to do this. Right. Let's clear all the output. So we have plotted spectrogram. Now, there may be other kind of chip signals. You can plot it for your own purpose. I don't want to plot it. Okay. And I think this is sufficient enough with respect to signal generation. Now, if you go to your drive now, there is an app. Can you see this? Sampling example.mlapp. Let's launch this app by double clicking on it. Let's wait by the time the app is being launched. So this is a sample app. Students, you can create your own app. This is front view of the app. And this is the code view of the app. Let me run this. So the app gets launched. Let me change the frequency. Let me change the sampling rate. So I can see over here, this is oversampled. There are very less sample. So it's unable, it's not easy for me to recreate the signal, right? Okay. So you can use this particular app, okay, to study the Nyquist criteria, the sampling kind of thing over here, right? Okay. So I hope you remember this twice of FS or Nyquist plot over here. Fine. So you can utilize this app. We are done with this part. Let's go to this sampling and Nyquist criteria. I think you all are about the Nyquist criteria, okay? And few of you might have also studied the channel carrying capacity. So, you know, if I transmit an analog signal, or the receiver grabs it or captures it, I need to reconstruct that signal. So as I told you that with every signal is associated the sampling frequency. In that case, what we are saying that this theorem states that if I have a signal and if I want to reconstruct the signal without errors from the sample taken at equal time intervals, the sampling rate should be twice or greater compared to the highest frequency component present in the analog signal. So to represent this mathematically, we are saying that Fs should be greater than 2f max or Fn is equal to twice of f max. We'll put it greater than or equal to, where Fx is the maximum frequency signal to be completed. Right? Okay. Let me explain you the code first, and then I will try and demonstrate it to you. Okay, dear students, please let me know if you face any issue. I will be happy to help you out. So I have a signal which is having a frequency of 1 kilohertz. If let's choose a sampling which is 10x time of the signal that we have chosen, which goes to 40. So Fs is equal to 40 into F. Let's create a time vector. Now you all are aware about how you are supposed to create a time vector, right? So T is equal to 1 by Fs. Okay. And then we calculate the length of the signal. Okay. So 6e minus t divided by t plus 1 will actually give you the length of the signal. Right? Okay. Now, we have this function x is equal to sine of 2 pi f t. We can construct our time domain signal. So what you can do is, like, you can have x is equal to 2 pi f of t, and you can plot the signal. So that this might be your time domain signal, original signal. Next, we create the computing optimal signal length for FFT. So this is 2 raised to next to power to L. You compute the FFT, you compute the absolute part, you complete the maximum, what you can say, magnitude part. Okay, we need to remove the negative components. Hence, we have taken 1 colon n by 2. We have not taken minus n by 2 over here, right? And we have got the frequency range. So this is how the FFT of the signal looks like. So now we can have a case. Now case is very simple. What it is, Fs is greater than twice of Fmax. If this is the case, then we should be able to recreate the original signal, right? Okay. If it is less than Fx is less than twice of Fmax, we may find out that, you know, we won't be able to recover all the samples. So the signal may not be properly reconstructed, as you can see over here. Right? And that's how you can go ahead and you can verify the Nyquist criteria. That is the sampling theorem. Fine. So we have completed module 1, which was generating and measuring the signals. So what you can do is, with me, what you can do is, you can go to MATLAB Academy. Let's click on signal processing on-ramp. I am sharing this link with you. We will at least try to complete the part course overview and signal data in MATLAB here itself. Okay, in our session itself. So that by the end of this session, we should be able to get the certificate. I'm waiting for some time so that you are able to access this on-ramp course. Okay, let's complete this. Let's complete this part. Let's click on start course. Let's click on signal processing. Okay, so as you have seen this video, let me click on next. Let me see if there are any issues with anyone to access the course. Okay, we will quickly complete this particular task. So see, it talks about generation of the signal, and it's asking you, why don't you plot a power spectrum of this particular signal and amplitude time? Okay, fine. And then it is telling you that, okay, we've already talked about this, you can create a vector using the colon operator, right? So if the task is take variable fs, which is 100 Hertz, and then it's asking me you create a time vector t, which starts with 0, colon, it's 1 by fs, colon, 1. So it says that specify a signal rate of 100 Hertz in a variable fs. Then you create a signal named t that extend from 0 to seconds 1. Okay, where the time steps are 1 by fs. Let's click on submit. Let me put a semicolon. Let's click on submit. And let's see if I've got this correct. So you know why I was able to do this? Because so easily, the reason is we have already covered this fundamental, right? Let's click on next. Let's complete this module. Now say it tells me that you need to create a sine function. So if I take a sine function over here, it tells me create a what you can say 5 Hertz sine wave signal name SIG. So the variable name is SIG. Okay, I have over here time t. Okay, and for f we will put 5. And then what it is saying us that you plot this signal, plot T comma SIG. Let's see if I am able to plot this. Plot the sine wave. Okay, let me put a semicolon over here. You can see I got this, right? Now, if I click on submit, you can see, I am able to complete this and I'm able to move to next step. Now, what is next? Next is it's asking us, okay, can you add some random noise? And then they're saying, okay, in order to generate the random noise, you can use this function. If you feel like you are unable to understand the concept, you may use this. Or if you're looking for a solution, you can click on see solution. You can get the solution. You can just see what it is talking about. Okay? Fine. I've taken it from here. Since we want to complete this model here itself, let's click on submit. So we have completed task 1, task 2, task 3 for this particular module. Now let's move to task 4. Now what is task 4? It says add the signal vector with the noise vector, name the output signal sig noisy, and then create a plot. So if you remember, in task 2 and task 3, we have created one signal which is SIG. So this is equal to SIG. Plus, what you can do is you can add noise over here. So you add the noise. What is next? Plot T, comma, SIG, NOISY, noisy. Click to run or execute this cell. And now you can look at, we have two waveforms over here. The first one was without noise and another one we have a noise. Let us try and check if we are getting this particular code correct. Right? Next. Now it's telling us, you have to use the signal processing toolbox and generate a square wave signal because it already supports square and sawtooth function. So how you do that is take S is equal to square, this function. Okay. It's telling us that the signal name should be square, SQ. The sample time should be T. Yes, of course, we are taking the same sample time, which is over there. It's asking us that frequency should be 5. Okay. And then it's asking us you need to plot it. So we'll take plot. It should be T, comma, SQ. Let's first execute this cell. Let's try to submit and see if we are able to generate it correctly. If not, we can go to hint. Or if you are interested in understanding the solution, how this could have been implemented, you can do that. Okay. Now see, I didn't need the requirement of the C solution because we have already covered this particular part. So if you click on next, what you'll find out, that I have already completed module 1 and I am moving to module 2. Similarly, you can move to module 3. Anyways, I'm going to talk about pre-processing over there, right? But for filtering and other things, we will come back to signal processing on ramp again. Now, why these things are important to us? Because when we move to machine learning, we will require all these fundamental terms. Okay, heading back to our section 4, modular curriculum, data processing. Now, this is a really important part that is going to help us in further session. Please let me know if there are any doubts. Let's go to the first example. Dear students, please let me know if you are able to access this. This should be your drive path, okay? This should be your drive path. Let's go to missing signals. Okay. See, when we go to data analytics or we go to visualization of the data, there may be a situation wherein some data is missing, right? In that case, I cannot go ahead and build a machine learning model because not a number, which you can see over here, the missed numbers or the missed readings will be set to NaN, and NaN stands for not a number. So in this particular example, we are considering the weight of person at recording in pound during the year 2012. And the person did not record their weight every day, right? So you go to a gym. If you're a fitness freak, okay, you will try to weigh your body weight by a schedule of a week or a day every time when you do exercise and come next day. But there may be a situation wherein you were unable to do this, and hence it led to creation of missing data. So what is the first thing? Load the data. So I will try, and I will also write who over here. So I get to understand that, what are the different variables inside this data set. Then over here, you're converting the weight from pounds to kg. I'll explain you what exactly we are trying to do. Don't worry. Okay. Then we are trying to find out the number of days, the weight was taken. We will find out that the missing weights values, and then we'll print that how many total days were there and how many values are missing. The first thing that we'll do is, let me put a section break over here. Okay. So let me type clear and CLC, and let me run again. Can you see that I told you that you can load the data? So that's how we are loading the data. And I want to look at this data set. So see, that is how this data set looks like. Now the second column actually represents the weight in pounds over here. Weight in pounds. So what we are saying that in this particular table, if I want to access weight, so how this could be accessed? This could be accessed as weight variable is equal to dataset name, extract all the rows, select second column, and divide it by a factor of 2.20462. So what we are saying, I will write down description for you over here. The description would be from the data set weight 2012, extract all rows and only weight column, right? Then convert each value of weight from pounds to kg. Let me remove the semicolons. Let's run this. Can you observe over here? I'm getting number of days over here. Number of days and missing. So number of days are 366, as you can see. If I try to do this, number of days are 366. Let's put a semicolon. And then someone would say, okay, what about this missing? What is this is NaN? Is NaN. Select this is NaN, right click and click on help. What is NaN? Determine which array element are NaN. So, if I take this, what you can say, 0 divided by dot. So this is element by dividing. So 0 divided by -2 is 0. 0 divided by -1 is 0. 0 divided by 0 is NaN. and rest are also zeros. So if I use this, that inside this variable A, is there any data item whose value is not a number? Return me the output in the form of logical array, right? So when you write is not a number A, at the index position 1, 2, 3, where you have the 0, I've got NaN. So when I check this array, I find out, yes, there is an NaN value present over here, which is not a number, right? So that's what we are trying to do. So if I go to my MATLAB and I try to check this, okay, missing is equal to is not a weight. You can say it's 0. So 0 is indicating that there is a weight present. Wherever you say it's logical 1, it will indicate that the weight is missing. Okay, can you observe? I can see weight 1. I can see 1, 1, 1. So what these are indicating that on this index location, weight is missing. And if I sum up this missing, if you see, instead of writing this, if I write sum, see missing is 27 if you see. I hope I am quite clear on this particular part. Does anyone has any issue over here? Now let's move ahead. Now, if I try to plot weight, let me add this and let me show you this. So there might be few changes which actually are not part of what you can say the original, what you can say, the scripts that have been shared to you. So, I understood that there are 27 missing values and the total number of days are 366. I want to visualize this data. So let's click on this and visualize the data. And let me open this figure in a figure window. So this is the figure window. I'll just like to show you certain areas where you'll find out that the values are missing. Let me insert rectangular boxes. Okay, you can find out, I see over here that the values are missing. This is one area between 50 to 100. Okay, I do have another area between, you can say 230 to 250, where again we see that the values are missing, right? How do we fill up these values? Now see, we are talking about some practical things here. How we fill up these values? What are the ways to fill up these values? One way is to resample or interpolate. One way is to resample or interpolate. So what could be done is, like, whenever you feel that the data is missing, you simply use resample, right? You simply use resample. So one way to do is to use an interpolation technique. So one interpolation technique is to resample. So we will simply resample, okay, weight according to the day's number. As you can see, this is a day number. Okay, this is weight, right? And we are plotting it, right? So this is dash dot. So you can see over here dash dot, dash dot. Okay. And O stands for a circle over here. So wherever the values are missing, we are interpolating that. And whenever the values are present, it is represented by, this dash and dot. Let's try to run this. And if you can see, we have kept the excess to be between 200 to 77. Now, what do you mean by that? Okay. So 200 to 250 is for y-axis and 73 to 77 are for the x-axis, because this is where you will find out that most of the values are missing. So now if someone tells you, okay, you want to interpolate, you want to find out the missing values in the signal, how you are going to do that? Someone will say, okay, we will replace the missing value by the max value in the entire data set for that particular column, or minimum value, or median value, or an average, or you can simply interpolate depending upon the trends. And someone can say, okay, is there any other way to find out this? Yes, there are other ways also. Like if you go to task, and if you see over here, you have clean outlier data, find and remove, smoothen the data, clean missing data. So when you click on clean missing data, you can think of either filling or removing the data. Please let me know if you want to see this clean missing data task. I will do that. I'll show it to you. Next. Now, what we want to do is like determine if the signal is periodic by analyzing it in frequency domain. Find the cycle duration, measuring time in weeks, subtract the mean to concentrate on fluctuation. Okay. So, we are using this p-Welch function. Now, what is p-Welch? Let's open the documentation, help on p-Welch. And what it tells you? It tells you that if you want to view the power spectral density and estimate it, you should use the function p-Welch. Go to your MATLAB. See, we have weight minus average of the weight. And here we are doing it for the week, hence Fs is 7. Just plot it. Okay, and see what this figure tells you. Can you observe this pattern, trending pattern, rise, then fall, and rise and again? So, okay, if you look at this figure, okay, it tells you that, that the person's weight oscillates 20 minutes. If the person weight oscillates weekly, if there's a noticeable pattern from week to week, okay, so there are 52 weeks, right? So what we can do is we can reshape this and we can try plotting the data. Look over here. Now this is the weight of the person. This is the weight of the person based upon week. And we can see that the weight is not same, that every week you will find out that it is fluctuating. But if you look at the last 2 weeks, 50 and above, you will find out that the weight is not same on each day and it keeps on fluctuating. How about smoothing the data to find out a better pattern? Okay, so to smoothen the data, you can execute this particular section and you can find out over here that how smoothing help you to betterly visualize it. So one can observe that if you have a blue line over here, the blue line is actually indicating the weight on Sunday, which is highest compared to the weight for any day in a week. I hope this is sufficient enough. Right? Okay. So I have 52 weeks, right? So if I want to take the weight of a person on Sunday, I have to add up all the weights on Sundays divided by number of weeks. Similar are the cases for number of days. And therefore, you'll find out that the mean weight from Sunday to Saturday is shown over here. And this clearly indicate that the mean weight on Sundays of a person is greater compared to any other day. Right? This is how we go ahead. Next. Okay. What we can do is we can go to removing trends from the signal and later on smoothing. So let's click on this removing trends. Okay, you can click on clear and CLC. Look over here. We are looking at an ECG signal. Now, what is an ECG signal? So to tell you, I'll take file new, don't save. The ECG signal as shown over here is made up of certain section. First, I will try to show you, okay? So you have over here, if I try to show, this is P peak. Then you have QRS segment followed by T. So again, this will keep on. So this is how a heartbeat signal looks like. If I want to name this peak, okay, it's asking me cancel. I will restart this. I'll restart this later on. Okay, let's go to MATLAB. Okay. So this is an actual ECG signal. So if you, because we are going to work on this tomorrow, it's important for me to explain you this. So this is P. You have over here Q. You have over here R. And this is T. So this keeps on repeating. So if I assume this is one cycle, it will keep on repeating. Now, when we try to capture signals in real time, there may be some issues while recording the signal. They may be like, they appear to follow a trend. Now, what is the trend? So the axis should have been like this, a straight line. It will indicate that there is no trend. Unfortunately, we find out that there is a trend, and due to which the signal has shifted and is moving along this orange axis. This indicates unnecessary bias in the signal. So this is known as trend, which is there in the signal. Another issue which you will find out over here is noise. So you might have observed that or you might have noticed that at your home, if you take your elders to health diagnostic centers, they will try to put electrodes. Observe this, okay? And these electrodes will be connected closer to the chest area where they want to monitor the heart rate. Now this electrode, since they're terminal, will also tend to add noise. So when we want to deploy an AI model, which may be either you're following a machine learning approach or a deep learning approach that we will see, what is important for us? The important thing for us to remove the trend and remove the noise. This is one thing. So this goes under data pre-processing. And the third one, which is really important, is after the pre-processing is being done, you need to go for labeler, that is labeling, signal labeling. So you label your data. And when you label your data, after all these three steps, you move to AI, wherein you can use supervised learning approach to classify, whether the signal is normal or abnormal. I'm writing AR, okay? Abnormal signal. Therefore, this exercise is important for us. Okay, moving back to the signal. Now, if I try to look at the original signal, I would see that there are trends in the signal. As you can see, I'll observe, I will make you things quite clear. Okay. Also, someone can help me in pointing out, okay, what exactly is happening. Are you able to see some lateral shift in the first part? Look at this point. The signal in both the figure appears to same, okay, when you talk about up from sample time over here, sample 0 to 600, up to 800. After 800, if you notice, in the first case, the signal is slowly try to follow the trend. Therefore, what is important for us, the important thing for us is to detrend the signal. Okay. Now, to detrend the signal, we use the function detrend. Detrend. Okay, as a function. Okay, let me check what is wrong. Detrend ECGL. Let me run this. Let me check. Okay, I have variable EC in GL with me. Execution stage of a function is not allowed. Okay, because we are already having detrend over here. Okay, anyways, okay, fine, not an issue. Now, if I want to detrain the signal, there are many ways to do it. I'll show you how you can do that. So there are multiple ways to do it. Okay. Okay. So this is with trends, and then we can have with detrend also. I will try to use over here. Let's go to home, apps, and let's type and have signal analyzer app. let's wait by the time the app is being launched. So you can see I've got the app. Now this is my app. I want to visualize this signal, ECGL. Just drag and drop. And you can see there is no need for me actually to write the script. But since you can see a trend over here, because it's a better visualization, I hope you might be able to see a trend. Slowly it's building up. Now, if you take this kind of signal, we will basically find out that we are not able to build up better, what you can say, AI algorithm. So we can do one thing. You can go to pre-process. When you get over to pre-process, you have an option over here, D-trend. If you want, let me know. I'll repeat this again. That's how MATLAB apps help you, okay, compared to other tools when you want to automate your task. Click on D-trend. You choose the method, constant, linear, piecewise. Let's choose linear. Let's click apply. So see, it's telling me signal in the signal table will be overwritten. Okay, I don't want this. So what I'll do is, let me cancel this. Let me go to grid. Let me take this. Okay, and it's fine. Anyways, I want to detrend it, so it's fine. We'll go to analyze. Click on pre-process. Okay, select the pre-process option. I am selected detrend. Over here, select the method. Click on apply. You can say OK. Okay, let me try choose some other method. Okay, so there might be some issue at my end, but anyways, I'm just showing you what you can do is you can select over here any particular option, and from here you can apply. So you can see now what I've done. I've applied a band pass filter application over here. Okay, you can apply a high pass filter application. Okay, if you want, as I've told you, you can take retrend, you can take missing values. Okay, or if you want, you can smoothen the signal. So there are a lot of things that could be done with the help of this particular app. Cancel. Let's cancel this. Yes, this is my original signal. Okay, but if you can see, if you go to measurements, time, display, you can get signal statistics. You can go to this peak, find peaks. What it will try to do is it will try to find the peaks. Okay, the peaks are located at this location. You can see over here. It will try to find out the peaks. Tomorrow we are going to delve in detail with the ECG signal plotting, removing noise, detrending, and other things over here. So I think we should stop this ECG signal for ECG signal operations for time being.
Hello, sir.
Yes, ma'am.
Yeah, I just had a doubt. Sir, we completed the task for the today, like second certification of signal processing. But then suppose the task 2 and 3, there is an error coming. And post that, how to download the certificate for that task? There is some students ask this doubt.
So if we go to signal processing, we are actually supposed to complete all the tasks. Like here you may see that when we are talking about pre-processing of the signal, okay, and I'll resume this because, okay, I'll go to, let me check filtering. Okay, so where they are facing the problem and
task like in 2, like I'm also getting some issues and in one task. So after that, other third task and fourth task is completed, corrected. And after that, how to generate the certificate? Okay,
so to generate the certificate, when you complete the course, you need to click on certificate and progress report.
Okay, fine.
If you click on certificate and view PDF, you'll find out it will show you that 12% have been completed.
Okay, fine. Yeah.
Okay, so like 12% is already completed. They can go and they can complete this things over there, right? Okay. Now, returning to MATLAB, like I'll quickly finish this particular part. Okay, signal smoothing and probably filter design. It's not that much required to us for this session, but we'll go with signal smoothing. Let's click on this. Let's type clear and CLC. See, all those codes are already being shared to you. Now, this is a really interesting thing. So, if you see, like most of the time, you might have noticed during monsoon season, when it's a heavy rainfall, the flights being getting delayed. And then the air traffic control tries to give important data to pilots. And the important data could be wind, velocity, and other sort of things, okay, with the visibility and all that, and the temperature, right? Okay. So NOAA is one such agency which capture this kind of data. So if you go over there, that is National Oceanic and Atmospheric Administration. You can go over there and you can download the weather data. So even though in this particular section, we are taking the data from year 2011, it's fine. You can go over here and you can download the data as required, right? Okay, forecast and all other sort of things. NOAA website, you can go and you can do that. You can download the things. So for this particular application, what has been done? In this example, we are using moving average filters, and we will resample to isolate the effect of periodic component, okay, with respect to time of day on hourly temperature readings. Now, what is the motivation? The motivation is now, since the temperature is not going to remain same, it's going to fluctuate a lot, okay, and if we smoothen it, it will also help us, in removing the noise, and will be also easier us to see that the trends do not provide such greater effect in our data. So in this case, what we are trying to do is, we will try to examine the data, we will smoothen the data, we will try to see a trend if it is there, okay. And for this, what we are doing is, we have taken a set of temperature readings in Celsius at airport in Boston for the month of 2011, July. Probably this could be winter, okay, fine. Next. So what is 1:33? Remember, 1:33 is for number of days. And right, you have 24 over here, which is 24-hour cycle. Fine. So you clear everything, you load the data, let me type who, and then we simply plot temperature in degrees Celsius, okay, with respect to the number of days in the month of January. Okay. Let's first try to visualize it. And then someone can say, okay, why we are looking at this particular data? Remember, this is a signal, and this signal is probably been generated by a temperature sensor over there. Then we can observe the pattern that from 0 to 10, what could be the average temperature, 10 to 20, 20 to 30, and so on. I could see that there are no missing values, so this is a really good thing for us. Next, I need to apply an filter over here, right? So what are the different types of filters that I can take over here? So see, the different types of filters that you can take are moving averaging filter, median filter, bandpass filter, and other sort of filters also. Anyways, what we'll try to do is, we will try to take a moving averaging filter. I'll explain you, okay, what a moving averaging filter is. See, why we have taken a moving averaging filter is because I had shown you the pattern, like between the 1st January to 10th of January, the temperature is almost below 5 degrees Celsius. So here I am taking a window of 10 days. Next, if we move from 10 to 20, we find that there is a rise in temperature. Okay, the temperature is close to 5 degrees Celsius for some days, and then, but we can say it's about 0 degrees Celsius. We can look at the values, X and Y values, okay, almost 1 degrees and all that. If we move to another window, between 20 to 30, we may observe that there is another pattern over here. Now, if we have a data of this kind, okay, so if we take this figure and you plot it like this, let us suppose 0 to 10. So in moving averaging filter, what you do is, like, you need to decide the window, and we keep on moving this window. So in this case, the moving averaging is done on the basis of 10 days. Or you can decide, okay, if you want to do it for a week or something like that. So if this is 0 degree for us, 5 degrees, 10 degrees, what the data is indicating that for the first 10 days, the temperature never crossed 0. Slowly after 10th day, it crossed 0, it went up to 5, then slowly dropped down. But it was close to 0. Now for remaining 10 days, it shooted up to 10 degrees. Okay, further got down. Now in all these cases, can you see, if we try to take an actual average, now what could be actual average? The actual average could be like, take the temperature of each day, add them, sum them, and divide them by 31. So you take all the temperature values and you divide by 31. This will be the average temperature value, right? This analysis could be wrong because it's not going to give you correct picture. Instead, if you take a moving average with and windowing kind of thing for 10 days or a week, that could give you a better approach. And that is what we are trying to do. So as an engineer, when we look at data set, we should be able to understand or notice this kind of patterns. So here you may find out, okay, what we are trying to do is, okay, this is an hourly temperature, and we are taking 24-hour average. So here the window is of 24 hours, while the concept which I am explaining you, it's for 10 hours. Depends upon you. As I told you, you can decide it could be for 24 hours, a week, 10 days, or it could be for a month also. Depends upon you. Okay, fine. I hope this is clear for you. Okay, fine. Now, when you take moving average, you may observe that a delay is added. A delay is added. We need to remove that delay. So you can filter the delay. To do this, you can see what we're trying to do is note the filter output is delayed by about 12 hours. What is the reason? The reason is that if you take a moving average filter, it obviously have a delay. We do not want this delay. We need to remove that delay. So what we are going to do is you're going to use a symmetric filter of length n. Right? And you might notice over there that a newer figure doesn't have delay over here. And this gives us a better representation of the data compared to the previous one. Now what you can do is, see, now you can go ahead, you can take a mean, you can take max, and you can perform all other things, okay? If you want to extract peak, you can do all such sort of things. Fine. Let me take a task over here because I'll take 5 more minutes. Go to live editor task, take a task, and you can see over here we have an option, find and remove trends, compute by, clean outlier data, smoothen the data, normalize the data, create the plot. Let's click on this, create the plot. If you remember, okay, you can select the data, right? So what do I need to plot? I need to plot temperature with respect to, if you go to this, what is the first plot? The first plot is temperature, right? Temperature with respect to days, right? Okay, go over here. You can select days. Okay, first you select temperature, click on add, and you select days. But you also need to select the graph, right? So what you can do is you can select a line plot or some other kind of plot over here. Let's click on line plot. Select a plot. And you may observe that I've got a plot. But you notice, you know what? My coordinates have changed. Y have become X and X have become Y. So, oh, anyways, we can do this, okay? Take over here, tempc. Can you observe? I've been able to plot this. And I do not need to write any code. Am I clear? Will this be useful to you when you do your project?
Yes, sir.
Yeah. So try to understand that, you know, when you are into second year, third year, third year, you will find out you write codes because you need to understand the fundamentals, right? But as you move ahead and you understand the fundamentals, that is what you will be doing. Now, just to conclude, see, when I go to government accounts and I talk with scientists, they work with so huge data. Most of the time, they do not have right to, or do not have time to write the code. They want fast results. So what could be done? They can use this kind of techniques. Further, let me add one more task. So if I go to task, and if I add a task like find or remove trends, periodic trends, let us suppose, or normalize the data. I want to normalize the data. Fine. Select this. You can select the data. Whatever is your data. My data is temperature. I'll select temperature. Okay. So the first one is original and the second one is, you can see over here, the normalized data. I don't know why this window is okay. See, you have to select different methods for normalization. One method could be range, z-score, center, scale. If you take center or if I take median IQR, okay, you will find out it is a different technique to normalize the data. Now, what is the difference between two figures? Let me launch this and let me show it to you. This will be useful for us, when we go and when we work with time series data for AI and kind of thing. So in the first figure, look at the x-axis. It's 0 to 800, but y-axis values are minus 15 to 15. But in the method which we have chosen, median IQR, interquartile range, okay, the values are between minus 2 to 2. Sorry, minus 3 to 3. I have the highest value over here. This gives you a better understanding of the data. If you feel like, no, I want to use some other method to visualize it, you can change it. You can change and you can take, okay, I want center. And when it is center, you take mean value or you take median. So I want to take median. You can copy all those results and you can paste it. Okay. Someone feels like I'll show you a few more things. Like I'm just trying to set up my foundation for the next class. You record an audio signal because tomorrow I'll be talking more about signals and audios. This was just an introductory kind of thing. You record your audio, and from audio you want to know the features. Okay, what you could do? Go to task. You have an option over here, audio. Can you see this extract audio signal? Let me clear all the outputs. I want to show you this. I want to select the signal. I can select the signal. And just to tell you, like those who are into third year, you might have studied DSP and you might have studied different windowing techniques like Hamming, Cassier, rectangular, and so on, right? You can find out over here that tomorrow we need to record our own audio. Also, we will use different audio cells. And then we will talk about different features. What are these features? Spectral features, septal features, spectral descriptors, periodicity features, energy features, display results, and so on. So if you find out, we have over here different categories of the features. So when we receive an audio signal, we may think of applying machine learning to it. In that case, we need to build up a tabular data. And in the tabular data, we may require different features. This feature may be some of the features which are listed over here. Okay, ZCR, skewness, standard deviation, kurtosis, MFCCs. Okay, all such features will be there. Right now, I do not have any signal over here. Let me try and see if I can load ECG signal. Okay, or any other signal like, I don't know, like if that signal is there, because I also need a sampling frequency. So let me just try and check if I can load the signal. Okay, if I take ECGL, it's fine. See, but then I have to take sampling frequency also. So really sorry for this moment. I do not have ECG signal over here right now. But yes, tomorrow when we come, we will be talking about starting with audio. We'll be building ML model around ECG signal. Okay. And then what you're supposed to do is you are supposed to complete this signal on ramp and MATLAB on ramp. So tomorrow what we are going to do is we will talk about the spectral analysis techniques, something like that. Okay, where we'll be interested in spectrograms and all other sort of things. So I think this is sufficient enough for today. Thank you, dear participants. I know this is a long day. So many things are there. Can you repeat today's task? Okay, see, today's task is to complete MATLAB on RAM and signal processing on RAM. Once you complete this, you should be able to submit those certificates. After submitting 6 certificates, I think you should be eligible to receive a certificate from your institute. Okay, thanks. Thank you. That's all from my side.
Thank you, sir, for conducting such a wonderful session on the day 1 of 3 days PDP. And participants kindly do complete the course and download your certificate. Thank you, sir. Any doubt, participants? Yes, sir. So I think no doubt. I'm sharing the feedback link on the chat box. Kindly fill the attendance cum feedback form for the day. 1 second. Yeah, please find the link of attendance cum feedback form of day 1. Tomorrow we'll be meeting at 10:30 for session 3. Kindly do complete the task.
Okay, so the deadline is, I think, tomorrow's deadline for them to submit the certificates.
Yeah.
Yes. Okay.
No, sir, we'll collect all the certificates at the last day. Is it fine?
Fine. Anyways, like they have to submit those 6 certificates. So
sure.
Even that is possible.
So we'll give a span of 3 days. On the third day, we'll third day we'll generate a Google form where you can upload all the 6 certificates.
Okay. Thank you, ma'am.
Thank you,
Shall I
sir.
leave the meeting then?
Yeah, sure. Thank you so much, sir. Thank you, participants. Kindly fill the form before leaving the meeting.
Yeah. Thank you.
Thank you so much, sir. Any participant facing any issue? Kindly access it through your Atharva ID, Atharva email account.